Welcome grade 12s to Euclidean geometry. Going to question 1. We're told that the radius is 5 units and we need to show that B is equal to 4. So the radius is the distance from the center to the circumference, so that is 5. Okay, so using the distance formula, we can prove that B, which is the y-coordinate of t, is indeed equal to 4. So let's do that. So starting with the x-coordinate, -2 minus 2 square those x-coordinates, and then we add the y-coordinates, which is b minus 1, and we square that 2, and all of that is equal to the distance of the radius, which is 5 squared. And of course this is -4 squared. Simplifying further, we have 16 5 squared is 25. If we take 16 over, minus 16, and of course if we take that'll give us 9, and we can take the square root of both sides and we're left with b minus 1, and of course this could be positive or -3, but as you can see the y value at b is positive, so we will only take the positive solution. So we've got +3, and of course if we simplify, then b will equal to 4. So we've proven that b is equal to 4. So let's go to question 2. Question 2, we are asked to find the coordinates of k. Alright, so k is on a vertical line, and we can actually use m to find those coordinates. If we look at the x-coordinate, of course the x-coordinate will be the same as m because it's on a vertical line. So if the x-coordinate for m is 2, then the x-coordinate for k will also be 2. And to find the y-coordinate, remember, we know that the radius is 5 everywhere. So if the radius is 5 there, the radius will also be 5 here. So the distance from m to k is 5 because that's the radius. So to find the y-coordinate, we can take the 1, and since we're going down, we get -5, and this will give us -4, and that is the the y-coordinate of k. So the coordinate of k will be 2 and -4. Let's go now to question 3. In question 3, we are asked to find the equation of line LTP, and we must write it in the form of y equals to mx plus c. So the first thing that we want to find is the gradient of line LTP. We want to find m. So we can actually use the gradient of Tm. So the gradient of Tm from t to m will be, let's take that as y2, it will be 1 minus b, which we know is 4. Remember, we calculated b in question 1, so b is actually equal to 4. So y2 minus y1 is 4 over x2 minus, so this is x2 minus x1, and of course negative minus 2 will give us +2, and this is -3 over 4. That is the gradient of Tm. Okay. Alright, now remember that Tm is actually the radius and LP is a tangent. And we know that the radius will meet the tangent at 90 degrees. And of course, that's also a theorem. So the radius will meet the tangent at 90 degrees. So what that means is that the gradient of Tm, which we just worked out, when multiplied with the gradient of this line, LTP, the line that we're looking for, it should give us -1. That means then that the gradient of this line, of line LTP, will be 4/3, because if we multiply those two gradients, then it should give us -1. So once we have the gradient of line LTP, we can substitute then into the equation. The gradient is 4/3 x plus c. Now, to find c, we can actually use t because it's the only point that we have on that line. So if we substitute the coordinates of t into the equation, of course, the y value is 4 and the x value is -2, which gives us -8/3 plus c. So to find c, we can simplify. So we've got 4 on one side, and if we take the 8/3 over, 4 plus 8/3 will give us 20/3. So c is equal to 20/3. Now the final equation will be y equals to m of 4/3 x plus c of 20/3. That is our solution. Let's go now to question 4. In question 4, we are asked to find the coordinates of P. All right, when this information at the bottom is very important. S is actually the midpoint of PK. And using the midpoint theorem, and of course, remember, we calculated in question 2 that the coordinates of K were 2 and -4. All right, so if we use the midpoint theorem, now the coordinates of P, we don't know. That's what we're trying to determine, the coordinates of P. So using the midpoint theorem, let's start with the x coordinate. Now the x coordinate, we can calculate by taking the x value of P plus the x value of K divided by 2, and we know that this should give us -4.5. That's how we can work out the x coordinate. To work out the y coordinate, we do the same thing. We take the y value of P and then we add the y value of K, which is actually -4. Okay, so this is actually -4. We divide all of that by 2, and we know that those should equal to -6 because that is the middle. All right. So x value of P plus the x value of K divided by 2 will give us -4/5, the middle. And for y, the y value of P added to the y value of K divided by 2 will give us the -6 here, which is the y coordinate. So now we may simplify. Of course, 2 times -4.5 will give us -9. This side. 2 times -6 will give us -12. So the x coordinate will be -11. And the y coordinate will be -8. So the coordinates of P are -11 and -8. Let's go now to the final question. calculating the coordinates of L. So this time we want the coordinates of L, and of course L is also on the vertical line, so we know that the x coordinate is going to be 2. So to find the y coordinate, we actually need to use the equation of line LTP, which we calculated back in question 3. I think let's just go back to that question. Yes, of course, that is the equation of the line LTP that we calculated, and we need to use this equation now to find the coordinates of L, because remember that line goes through L. So let's do that quickly. So from question, we know that the equation of this line from question 3 is 4 over 3x plus 20 over 3. Alright, so to find the y value, we need to use that equation. So we can substitute the x value because we know that that is 2. So we have 4 over 3 and we just substitute 2. And this should give us the value of y. Okay, so we have so the y value is 28 over 3. So that is the y value, 28 over 3. So the coordinates of L are 2 and 28 over 3. Thank you, grade 12s.